Welcome to Lesson 9.6, Interpreting Graphs. To begin, let's review a little bit of 9.5, write and evaluate a function for the given scenario. So go ahead and pause the video, and when you're done with these problems, we'll come back and try them together. All right, so if we look at this first problem, it says that Anna reads 13 pages of her book every day. So another way to think about this is that she reads 13 pages per day. Now we need to start by defining our variables. Our variables are going to be P for pages. You could use something different. I just think that makes sense. And D for day. All right, so we know that in one day she can read 13 pages. Or excuse me, sorry. In one day she can read 13 pages. So because it's pages per day, we want to take the number of days and multiply it by 13. And so that word that comes after per is going to be multiplied by our constant of 13. So this is going to be our function. So then it says, how many pages did Anna read after the 15th day? And we're going to do P equals 13 times 15. 15th day is our D variable, so I'm going to replace this D right here with 15. And when we do 13 times 15, and 13 times 15 is 13 times 15 is 195. So since this is a word problem, we want to answer it with a full sentence, and we're going to say, Anna read 195 pages. All right, so let's look at what we've got for today. So we've been looking at different types of graphs, and one important thing to know is that not all graphs can be represented by a function. We looked at things like 2x plus 3 in that graph, and it made a straight line. But sometimes graphs are used to tell a story, or we use a story to make a graph. We are going to work with them in both ways. So let's see what we've got. Here's an example. This says we're looking at Sue's drive in the country. And this graph looks a little confusing if you don't know what it's about, but because we have this title, we know what it's about. We can see that Sue left her house around 9 o'clock, and she drove, and then she stopped, and then she drove some more. She stopped, and then she started her way home. And we're going to talk about how to tell what all of this means. But we're going to start practicing some storytelling. So today's kind of fun because you get to be a little bit creative, I think. Hopefully you get to be creative. All right, so Claire decided to go for a run. The graph shows her distance from home in relation to time. Describe what you can from the graph. So we need to know what's happening here. As this axis moves this way, what's happening? Our time is increasing, or the more time has passed. So time is passing. It's not going backwards, we're just continuing forward. So maybe we started at 0 minutes, and then they didn't give us any kind of labels, but I mean, maybe this is, I don't know, over 60 minutes or something. I'm just making that up. It doesn't tell us. Sometimes it'll tell us. And then this is the one that's really important to read. This says distance from home. So distance from home means if this is 0 right here. So what does this point right here mean? If it's 0, it means that she's at home. So the farther away from 0 she gets, that means the farther from home she gets. The farther from home she gets. And then, so we see that she's going to travel. She's going like this. And she's going for a run. We know that. So this looks like she's, we're going to say Claire runs at a constant rate. And this is important. This phrase right here, constant rate or speed, either one is fine. It's important, this word constant, because her speed isn't going like this. She's not changing her speed. She's traveling at the same rate. It'd be like if you got in the car and you set it on cruise control, which is where you like push the button and then the car just travels. You don't have to push the gas pedal or the brake pedal. It just goes on its own. So she runs at a constant speed. And then because we don't have any measures of time, we're not going to say for how long she ran. But then we see here, this is still a constant speed. It's not all wobbly like this up here, but it's a shallower line. So we're going to say maybe she stopped running and maybe she started walking. So I'm going to say after a while, she started walking at a constant speed. Okay, so that constant is still in there. That's important. And then finally, we see that she's keeping that constant speed, but now what this means right here is that she's headed home because she got as far away from home as she was going to get right here. And then she says, all right, I'm done. So maybe she decided she needed to go home, have some lunch or something, but it's not as steep of a line as it is here. So it's not as fast of a pace, but it's definitely steeper than it is here. And so she's not walking. Here she was walking. I would say that this is a run. And so maybe here she's jogging. Then she jogged home. Now, you can be as simple as that and leave it, but I hope that you can have some fun with this. Maybe you say Claire walked outside and started getting chased by a bear, and then she lost the bear, so she started walking to catch her breath, and then she realized she needed to get home for her bear spray. I don't know. Make it creative, but this is a chance for you to have some fun with it. But this is the basic what I would need to show what's happening in the graph. All right. So let's just talk through this one. I'm not going to write anything on this one. It says Charlie rode his bike from school or home from school. This graph relates time and his distance from school. Describe what you can from the graph. So this one has some times on it. It's got 0 to 60 and 0 to 60. So what I would say happened here is that Charlie left school and rode at a constant rate for, if we look at this, looks like it was about 30 minutes. So he rode at a constant rate for 30 minutes. I would expect you to write full sentences. I'm just jotting some notes so that you've got them, 30 minutes. And then his distance from school right here didn't change. So what that tells me is that he rested or stopped, one or the other. And it looks like he stopped for about 10 minutes. Then he continued to ride home for another 20 minutes. And it looks like he was traveling at about the same rate. So maybe say continued home at the same rate for 20 minutes. Again, I would expect full sentences in your answer, but these are the basic things that you would need to include. You could make that way more intriguing. You could talk about Charlie and his friends and the fact that maybe they stopped for like some McDonald's or something. I don't know. Make it fun. Have some fun with it. All right. Now we're going to go the other way. So we're told a story and we have to sketch the graphs. So, change colors up. Victoria rode the bus partway to the mall. When she got off the bus, she waited for her friend Gabriella to arrive. Once Gabriella arrived, they walked to the mall together. They spent some time and shopped. When they were done, Victoria took a bus home. Sketch a graph to show the distance Victoria traveled compared to time. So time is pretty much always going to go down here. Time is always going to go on the bottom. And along here, they've told us the distance, we're looking at distance Victoria traveled. So I'm just going to call that distance traveled. And then they didn't give me any measures of time, so I am not going to label anything except the zeros. Those are the only things I need to label. So it says that she rode the bus partway to the mall. Well, a bus is going to drive at a pretty constant rate. And it's going to maybe look something like this. I don't know. Something like that. And it says when she got off the bus, she waited for her friend, Gabriella, to arrive. So she traveled a certain distance to get to the mall. But then when she's waiting for her friend, she's not traveling at all. She's just kind of sitting there waiting. She's sitting in one spot waiting for her friend. And it says that once Gabriella arrived, they walked to the mall together. So walking is going to be a little bit slower than taking the bus. So my line is going to look more like this. Okay. They spent some time and shopped, so they shopped for a little bit, so that's not going anywhere, that's just hanging out at the mall. And then Victoria took a bus home, so that's going back to that faster rate. Now, you could make this part shorter or this part longer, but the idea is that I should see 4 things. I should see rode the bus, that she waited, I should see they walked, and then spent some time, and then took a bus home. So there are 5 pieces, and I see 1, 2, 3, 4, and 5. So these are the 5 elements that I would need to see in a graph. All right, so Joey's mom drove him part of the way to school. So that's one thing that happened. Joey waited for his friend and walked the rest of the way to school. After school, he took a bus home. Sketch a graph to show Joey's distance from home compared to time. So again, I'm going to put time on the bottom down here. But now, instead of just being distance traveled, it's distance from home. So this one's going to look a little different. Okay. So we're going to assume that he starts at home. And so Joey's mom drove him part of the way to school. So he started off and mom's driving. Thanks, Mom. So nice of you to drive me. And then it says he waited for his friend. So if he waited for his friend, he's not traveling at all. He's just kind of sitting in one spot. So he stays stationary. And then he walked. So he walked to school, but that's a slower rate than driving because I don't walk faster than a car. I don't think you do either. Maybe you do. I don't know. And then after school, he went to school. And so like he's at school, he's not going anywhere for a while. But then he took a bus home, and that bus is going to travel at a constant rate. Ooh, and I ran out of a little bit of space. So hopefully you can draw a little bit of a better straight line than I can on my laptop. But it needs to go back down to 0 because this represents the distance from home. We know that he's not that far from home, or he starts at home, excuse me. He travels away, but then he comes back, so it has to end back at home. All right, ignore this part, the quiz over Quiz Friday over 9.4 to 9.6, and just do these problems out of the book. Do these 6 problems. It should take you maybe 15 minutes, maybe 20. Have some fun with the stories, but then you should also be drawing graphs. For the stories, instead of writing them on paper, go ahead and type them into Google Classroom and upload those, but then go ahead and upload a picture of your graphs. Thanks, guys.